Okay, this video is specifically about converting to standard form. So standard form is when the equation is in the form ax plus by equals c, where a, b, and c are all integers, no fractions allowed, okay? So let's start with the first one. We'll do a few different examples. The first two problems here start off in point slope form, where we can see a point such as 4, 3 with a slope of 7/5. That line works that way. This one, the second one, also we have the point 1, -7 with a negative slope of 3/4. And this last one isn't in any particular form at all, but it's still a linear equation. It has an equal sign, it has an x, it has a y, nothing's raised to any powers, still a linear equation. So let's start with the first one. First thing I'm always going to do, especially because I'm going to standard form, which has no fractions, is I'm going to clear that fraction. So we are going to MPE 5. All right, that's always the first thing I'm going to do. That makes the left side 5 times greater than it is, 5y minus 15. And it takes out this 5 in the denominator, leaving 7 times the quantity x minus 4. Now, typically, I will distribute in the same step. I didn't distribute in the same step this time. But because the 5 only acts really on the left side, I tend to just do the 7 times the x minus 4 on the other side in the same step, even though I'm showing it in 2 steps here. Okay. Now I got to get the 7x to the left side and the negative 15 to the right side. So we are going to SPE 7x. And at the same time, I'm going to APE 15. So that's going to leave negative 7x plus 5y. And so the 7x is gone, but the 15, I'm moving to the other side. I'm adding it to the other side. So that leaves me with negative 13. And we're in standard form. That's done, right? Now, I would actually prefer the leading coefficient, this negative 7. Coefficients are numbers that come before variables. I would prefer that negative 7 to be positive. So I might MPE negative 1 here just to finish it off, negative 1. So that's 7x minus 5y equals positive 13. We have to make sure we change each of the 3 signs. Right? So do another equation here, another example. So we have y plus 7 equals negative 3/4 x minus 1, or times quantity x minus 1. I'm going to start off again with MPE, and this time I'm going to do 4, this denominator number. So that's going to be 4y plus 28. And then negative 3, I'm going to distribute also. I'm going to distribute in one step. You can follow this. Negative 3 times x is negative 3x. Negative 3 times negative 1 is plus 3. All right. Then I'm going to move the 3x to the other side. So we're going to APE 3x. And maybe at the same time, I'll SPE this 28. Subtract the 28 from both sides. All right, so the 3x, we wind up with 3x plus 4y. Moving the 3x to the left side. And the 28, we're going to be subtracting. That leaves negative 25. In this case, the 3 here is already positive. So I'm not going to change it. Not that you have, in this last one, you didn't have to change that in the maroon one. You didn't have to. But I said, I like that first term to be positive. All right, so both of these are good answers. But this is, in fact, a good answer also. This is totally fine. All right, then we'll do the last one here, the green one. Let me see, I'll get the green pen out. So again, I want to get rid of this 7. So we're going to do MPE, but it's set up a little differently here. We're going to multiply both sides by 7. We've been multiplying the right side by the denominator. It's just it cancels out. Here, it doesn't quite work the same way. So we have 7y on the other side. 7 times x plus 5 divided by 7 is just x plus 5. But we also have to multiply the 7 times the 2. All right, to get the 14. All right, so we can't just leave that 2 there. When we multiply, remember we multiply every single term in in the equation. So let's see. We're going to move the x to the other side. So let's SPE x. So that's negative x plus 7y. The 5 and the 14 we may as well add, and we're done. Unless you'd prefer to go to x minus 7y equals negative 19, which I would prefer, but it doesn't really matter. This is in standard form, and this also is in standard form. So every single equation in standard form has exactly two equations that make up the same line. If you go to graph these two things on Desmos, they will make up the same line. It's just the negative signs kind of undo each other. That's all there is to it.